So this is the video for the study guide of the next test. The next test is coming up soon. It's going to cover conics. It's also going to cover some polar equation stuff. On the study guide, which is on the web, you have 10 problems. In this video, I'm going to go over how to solve these problems. Some of these I'm going to do fairly quickly because you should really already know it. Others I'll spend a little bit more time on. This first one, I'm going to go fairly quickly. It says, which equation does this graph represent? The graph looks to be a circle, and if you look at the answer choices, A, B, C, and D, they're all in forms of circle equations. Remember, the circle equation was x minus h squared plus y minus k squared is equal to r squared, where h, k, and r are important parts. H and k are the coordinates for the center. R is the radius. If you look at this circle right here, I would say that the center is at the point -3, 1, and I would say the radius is the distance from the center to the edge of the circle. That radius looks to be 2. So if I just simply fill in numbers, I'm going to have x minus -3 squared plus y minus 1 squared is equal to 2 squared. And just simply, yeah, the bell's ringing, x plus 3 squared plus y minus 1 squared is equal to 4. The only answer choice that one matches is answer choice C. That's the only one. X plus 3 squared, y minus 1 squared is equal to 4. Should be fairly straightforward. Circles aren't so bad. The next problem asks you to identify the parabola. And if you think about this, the parabola is a U shape. Now, in all 4 of these pictures, there's 2 cones put together and a plane that intersects, and that's how we started to talk about conics. A parabola is a U-shaped figure. The only figure that's U-shaped, where the intersection is answer choice C. Now, if you're wondering what the others are, answer choice A is a hyperbola, answer choice B is a circle, answer choice D is an ellipse. And again, it's pretty straightforward there. Next question, in my opinion, is just as straightforward. It asks about identifying the equation of the ellipse. We have 4 choices there. All of those are in the form of the general form of a conic. Now, if you'll think back to some of the talk we had about this, you can already rule out answer choice C. You can rule that out. And the reason you can rule that out is there's only one squared in that. If there's only one squared, it's a parabola. We want an ellipse. Since all the others have more than one squared, we now have to face the fact that they could be circles, they could be ellipses, they could be hyperbolas. All those equations have x squared and y squared. So how do we differentiate an ellipse from a circle versus a hyperbola? What we look at are the coefficients of the x squared and the y squared. More specifically, what we look for are the values and the signs. For an ellipse, we need different values, but same signs. Answer choice A fits that because the coefficient of the y squared and the x squared are different numbers. They're both 6 and 3. But while those are different, the signs are the same. They're both negative. Therefore, that must be an ellipse. It has to be. B can't be an ellipse because the coefficient for the x squared and the y squared are the same numbers. They're different signs, but they're the same values. And D, they're both the same values, but they're the same signs. We want different values, but same signs. A has to be the right answer there. All right, number 4 says find the standard form of the equation of the specified ellipse, and you're given some information, the foci and the major axis of length. Now, if you want to do this out fully, make it a little bit smaller here, I would suggest that you first graph it. I know I have foci at the point -3,5 and -7,5, which means that my major axis must be horizontal because the foci are on the major axis. Which means then that I must have an ellipse equation that looks like this. X minus h squared over a squared plus y minus k squared over b squared is equal to 1. And the reason I have it like that is since I have a horizontal major axis, the a squared is located under the x. Remember in the ellipse, the a and the b switched. If the a is under the x, you have a horizontal major axis. If the a is located under the y, you have a vertical major axis. Now all we got to do is put in numbers for h, k, a, and b. Well, h and k are the coordinates to the center. The center, which I'll do in blue, is the exact middle of the foci. There's a distance of 4 between both foci. Half that distance is 2. Therefore, my foci are 2 units away, aren't they? Right? So my foci have to be 2 units away. Moreover, I know I have a major, let's finish the center point. That means that the center must lie at negative 5, 5. The center must lie at the point negative 5, 5. Which means then that what I have is x minus negative 5 squared plus y minus 5 squared. All that is over a squared and b squared. Now we got to figure out what a and b are. Well, a, if you remember, is the distance from the center to a major vertex. We know that the major axis has a length of 8. We know that. We also know that the major vertices have to be beyond the foci. So if my major axis has a length of 8, that means each major vertex is 4 units away. Half of 8 is 4 units away from the center. So I go all the way over to negative 1, and then all the way over to negative 9. If I wanted to draw it out. But the point is that my distance from my center to my major vertex is a distance of 4 right there. Therefore, A must be 4. So if you want to stop and copy this down, make sure you do that, because what I'm going to do now is take my eraser, pull up, I'm going to take this A out, and I'm going to replace it with 4. A is the distance from the center to a major vertex. Now all I got to do is put in B. B is the distance from the center to a minor vertex. I don't know where my minor vertices are. I just know they're above and below the center. But I do know this. There's a relationship between C and A and B. C squared is A squared minus B squared. C is the distance from the foci, from the center to a foci. That distance is 2, because it's half of 4. In other words, the distance from here to here is a distance of 2. A, we already know, is 4 minus B squared. So if you just do some algebra, B is going to be the square root of 12. B is going to be the square root of 12. So here's what I know then. Again, I'm going to erase the B here. So if I take this B out right here, I have square root of 12 squared. Now if I want to clean this up, I'll just do an arrow over here. Here's what I have. I have x plus 5 squared over 16 plus y minus 5 squared over 12 is equal to 1. There's only one answer choice that fits, and that is answer choice D. D as in dog. Now, I could have shortened this up some. I could have actually figured out that if my if my major axis is horizontal, I could immediately eliminate B and C as answer choices. Immediately. Because in those cases, my A is located under the Y. That would have made it vertical. We're horizontal. So just by simply looking at that, I could have eliminated B and C altogether. If I also recognize that the center point is negative 5, 5, that means I must be in the form x plus 5 squared, y minus 5 squared. squared, which D is the only one that works that way. So I could have actually done this without going through all this work, but I just want to point that out that this is a way you could do it. So the answer to number 4 is D as in dog. All right, number 5 is a polar graphing. And we learned this recently. Polar graphs are always circular. They're made of concentric circles from the origin. Each one is 1 unit further away from the origin. There are 6 circles there. So the last circle is 6 units away from the origin. The next to last is 5 units away. The next one before that is 4 units, all the way down to 0. So if I look at this point right here, this point is 4 units away from the origin. So I know then we're on a polar graph, therefore everything is in terms of r theta. I know my r then must be 4. Or it could be negative 4. So unfortunately, from our little perspective, I can't rule out any answer choice just by that. So what I have to do is consider the fact that my point is formed by making a rotation and then walking. I just erased that line up there. Making a rotation and then walking a directed distance. So really the better way to do this, in my opinion, is to look at the answer choices and work backwards. For example, if A is the answer choice, if it were, then what it's saying is that you face positive polar axis, the positive x-axis, and you rotate pi over 6 radians, which will put you in an angle like this. But then it says to walk negative 4. In other words, instead of walking forward this way, you walk backwards this way 4 units, and that's going to land you exactly on that point, isn't it? So really what that's saying is that answer choice A has to be the right answer. So the answer to this one is A. Now let's explore why B, C, and D aren't the right answers. All right, so let's say that you're not sure, so you want to look at B. All right, here again, B, well, I'll do this one in green. I'll erase this. B, what we want to know, how do we get that point using that coordinate? B is saying to make a rotation of pi over 3 radians, which is 60 degrees, if you will remember. And then because this is positive 4 right here, it's saying to move forward 4 units. So that puts us where my green dot is right there. That's nowhere near being on top of that black dot. So therefore, B can't work. I'm going to keep this dot right here still as blue. A is the answer choice. I'm going to keep it as blue. Let's look at C. If C were right, then what C is saying is that we rotate pi over 6 radians, which looks like to be the right angle, but because 4 is positive, it means that we walk 4 units and we land right there on that red dot. That's not where the blue dot is. And hopefully you can see D won't work because D, I'll do that one in black, you go pi over 3 radians, but then you walk backwards 4, and you land back down here. So A has to be the correct answer because of the way you make that point. You rotate pi over 6, and then you walk backwards 4 units. This next question, I'll make it a little smaller, deals with the hyperbola. And if you did the Google Classroom assignment and watched the video, you learned a lot about the hyperbola. The hyperbola and the ellipse are very similar in what they look like. They're both x minus 8 squared, y minus k squared, where h and k is the center. And then you have a squared and b squared, where a squared and b squared represent both a horizontal and a vertical framing, just like in the ellipse. The big difference in the hyperbola versus the ellipse is that there's a minus sign. There's a minus sign. I just went through it, sorry. The big difference in the hyperbola versus the ellipse is the hyperbola has a minus sign between the two, and ellipse has a plus. Also, the x and the y change in the hyperbola. The a and the b stay the same as far as their location, their position. X and y change positions. In the ellipse, it's the other way around. X and y stay the same and a and b change. But in the hyperbola, x minus h and y minus k squared are the ones that switch. And where they're located tells you whether your axis is horizontal or whether it's vertical. Now, if I take this equation right here and rewrite it, really what I have is this, is x minus 0 squared over 5 squared minus y minus 0 squared over 6 squared is equal to 1. This is a hyperbola. And if you look at the equation, the x comes first. X is first. We go from left to right, reading it. X comes before y. Now what that means, and I'm going to make this a little smaller now. Let's see, back that up. What that means, let's try to make it smaller again, is one more try. Well, it's not going to work like I want it to. So I'm going to move it. Since the x comes first, what that means is that your axis of symmetry, your transverse axis, is horizontal. The x is first, your transverse axis is horizontal. What that also means is that your center is the point 0, 0, and your vertices are located at the tips. Now, I'm going to do them in green right here. Moreover, your foci are inside the figures along the transverse axis also. Now, just like the ellipse, the equation to the hyperbola tells us something about where the vertices are, where the center is, where the foci are, all that kind of stuff, and what the also what the asymptotes are. Now, in the video that you watched, the guy that taught that, what he did was he made a box. My box isn't perfect. And the framing of that box is determined by what the A and the B are. And the diagonals of that box go through the origin, and they're also the equation to the asymptotes. Right? Now, that being the case, then let's start figuring this out. It doesn't ask where the center is. The center is 0, 0. It asks where the vertices are. Now, if you think about this, the vertices are always going to be A units away. Since the A is located under the X, that means they're 5 units away horizontally. Again, the vertices are always A units away. Since the A is located under the X, that means that they are 5 units away. So the vertices are the points, a green marker, the vertices are the points 5, 0, and negative 5, 0. Now, it's kind of busy on the graph there, but my vertices have to be the points plus or minus 5, 0. Plus or minus 5, 0. Now, that right there rules out everything but answer choice C. So if you feel comfortable about what you're doing, you can stop right here and move on to the next problem. Because there's only one thing in there that has plus or minus 5, 0 as your vertices. But just for continuity, I'm going to go ahead and find the foci and the asymptotes and all that stuff. Right? The foci. The foci are always C units away. And we have a relationship with the ellipse, with the hyperbola, just like the ellipse, that relates A, B, and C together. The only difference is now it's C squared is A squared plus B squared. C squared is A squared plus B squared. Right? We know A squared is 25, isn't it? We know B squared is 36, isn't it? So C squared is equal to 61. Therefore, C is the square root of 61. Which means that your foci are at the point negative square root of 61, 0, and square root of 61, 0. Or in other words, your foci are at plus or minus square root of 61, 0. Again, I recognize we could have stopped after we found the vertices and moved on, but that's how you find your foci. And then the asymptotes are the equations of the diagonals. If you think about this, students, since the A is located under the X, A is 5 units away horizontally, the B is located under the Y, so B is 6 units vertically. So here's what we have. We have a point right here. This is the point 5, 6. Moreover, this is the point negative 5, 6. We know we cross at the origin. That is a linear equation. So our y-intercept is the origin, which means that our linear equation has to be y is equal to the slope 6/5 times x. Since we have two of them, we have plus or minus. So that's why C is the correct answer for that. Is it a lot of work? Yes. Like I said, if you feel confident with what you did, you could have stopped at the green, figured out the vertices, and moved on because of our answer choices. Our next question. The point in rectangular coordinates is given. Convert the point to polar coordinates. So we learned the other day that we can do this in the calculator. The problem is it's not going to give us the answer the way we want to. But just so you'll see it, here's our calculator right here. Right? And it says that we have a rectangular coordinate of -5, 5 squared root of 3. And we want to go to polar. And all our answers are in radians. So I'm going to make my radian, my mode, a radian. Okay, this thing is not wanting to cooperate. If it doesn't cooperate like I want to, I'm not going to worry about it too much. I want my mode to be a radian. And then what I'm going to do, I'm going to hit second apps, and I want to go from rectangular to polar R. So I'm going to go down, and enter, and I'm going to put in my point, -5, comma, 5 square root of 3. And that gives me a polar R of 10. Now, unfortunately, that might rule out D, maybe, but really it doesn't rule out anything right now. And then if I were to, again, go to my angle, go to my angle button. All of a sudden, my computer doesn't want to do this. Try it one more time. Go to my angle button. This time I want to do rectangular to polar theta. Again, I'm going to put my point in, -5, comma, pi square root of 3. I get 2.09435 just like that. So by using the calculator, it gives me this point right here. It gives me 10, comma, pull that back up, 2.09439. 2.09439. Now I got a choice. I can see which one of those angles is 2.09439 and work it that way. But I also want to point something out. In the rectangular plane, -5, comma, 5 squared root of 3 is somewhere in quadrant 2, isn't it? So if we look at our angles up there, all of those angles are angles in terms of pi over 3, but C and A are both angles that are located in the first quadrant or the third quadrant. Neither one of those can work because an angle located over here is not going to land you in the second quadrant whether you move forward or backward, and an angle located in here is also not going to land you in the second quadrant, whether you move forward or backwards. So we can already eliminate answer choice A and answer choice C. Now we got to look at B. Well, B says to rotate 2 pi over 3 and then walk 10. It says to rotate 2 pi over 3. And I'm sure if you took 2 times pi divided by 3 is probably 2.094 something. But to get to this point, what it's saying is to rotate positive 2 pi over 3 and then walk forward to there. Remember, you're think of yourself facing the positive x-axis, and your nose turns to where all of a sudden you were facing this direction here. Positive means you walk towards there. Answer choice B has to be right, because answer choice D says to go 2 pi over 3, but then walk backwards 10, because that 10 is negative. We don't want to do that. We want to go forward. So therefore, B has to be the correct answer for this. B must be the correct answer. All right, this says convert the rectangular equation to polar form. And again, you can put this in the calculator, but since my calculator is messing up, I'm going to do the algebra with this. Okay, now there were 4 equations that you need to know to do this kind of stuff. Remember, one of them is x is equal to r cosine of theta. Y is equal to r sine of theta. Tangent of theta is y over x. And r squared is equal to x squared plus y squared. Those are the equations you're going to work around. How then can we convert the top equation into a polar equation? Well, the first thing you have, x minus 1 squared plus y squared is equal to 1. You've got an x squared and a y squared in there, but the problem is, with x minus 1 squared, you need to FOIL that out, that x minus 1 squared. So if I FOIL out x minus 1, in other words, if I multiply it, I'm going to have x times x plus negative 1 times x plus negative 1 times x plus 1, which is x squared minus 2x plus 1. So that means this thing is x squared minus 2x plus 1 plus y squared is equal to 1. Okay, now, remember, we have A, B, C, and D as our choices, and I guess from here, you may could try to figure it out. Now, I'm going to erase part of this. If you haven't copied it down, pause this and copy it down. I can rewrite this as x squared plus y squared minus 2x plus 1 is equal to 1. Well, now, x squared plus y squared is the same thing as r squared. Now, what I'm going to do is I'm going to go ahead and throw this to the other side. So that's 2x minus 1 plus 1. Okay, now, minus 1 plus 1 means I have r squared is equal to simply 2x. Minus 1 plus 1 goes away. And then if you remember, x is the same thing as r cosine of theta, isn't it? So r squared is equal to 2 times r cosine of theta. We don't want this in terms of r squared, we want it in terms of r. But if we divide both sides by r, then we are left with r is equal to 2 cosine of theta. Now, our equation up there is a circle with a radius of 1 centered at the point 1, 0. If you were to graph in your polar graph 2 cosine of theta, you should also get a circle centered at the point 1, 0 with a radius of 1. In fact, I am going to try to pull that one up and graph it. All right, the first thing you need to remember is that your mode, if you're going to graph, you need to be in degree mode. That works better for graphing. And you also need to be in polar mode. And then your window you should set it up to 0, 360, and 5 for the top. The rest of it doesn't matter. So if I go to y equals, and I plot this, if I plot 2 cosine theta, right now, I know my graph doesn't look too good. In fact, I guess I will try to change the window to make my x minimum, let's make it say -2, and my, oh, I'm sorry, I shouldn't do that. I need to make that one 0. I should make my x minimum -2 and my y minimum 2 and my y max also -2 and my y min 2. If I graph that, well, you get a crazy graph, but what you have is a circle centered at the point 1, 0 with a radius of 1. Now I know this graph looks crazy, and the reason it does is the way I set up my window and my steps. If I just go back to a zoom 5, it's not going to look quite so crazy. Well, maybe it does. Zoom square. Let me do this one more time. Okay, I'm going to go to a standard window. I'll leave that one alone. Now your graph might not look exactly like that, but that is a circle centered at 1. It just looks a little crazy the way it's done. But everyone should see how we got the equation r is equal to 2 cosine of theta. Whether you're actually able to graph it or not shouldn't matter. Okay? This one says find the standard form of the hyperbola. Again, if you look at it, now this is a bit deceiving. The hyperbola is this part right here that I'm doing in blue, but it's also this part right here. So if you look at this, this must have a transverse axis that is horizontal, which means that our equation has to start with x. Now, unfortunately, I'll still start with x, so that doesn't change things. It also means that the center, the HK, has got to be the center of this right here. Now, I'm going to erase some of this so that we can be clear here. So the center is going to be the midpoint between this segment here. If I look at this, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots. So if I go 5 dots away, 1, 2, 3, 4, 5, right here would be the center point. That's the point -4, -1. Which means then that I have x minus -4 squared plus y minus -1 squared over a squared b squared is equal to 1. And I've already made one mistake. Let your teacher have this mistake. This is a hyperbola, so it must be a negative, a minus. Sorry about that. Okay, now we're not going to worry about a squared and b squared right now. This is just simply going to be x plus 4 squared over something minus y plus 1 squared over something is equal to 1. Now, if you just simply look at that, that rules out everything but answer choice C. That rules out everything but answer choice C, because everything else is in terms of x plus 1 or x minus 1 or something like that. Our equation should be x plus 1, y plus 1, or x plus 4, y plus 4. Now, if we want to, we can go ahead and do the A and the B part of things. Remember, A is the distance from the center to the vertex. The distance from the center to the vertex is the distance of 5, so A has to be 5 squared. And then we have B. Well, B is going to be this box thing. If you look, in every case, B has to be 4. In every case, B has to be, well, I should have circled it that way. What I'm saying is that if A is 5 squared, B is going to have to be 2 squared. If you don't understand why, don't worry about that. We would need to know what C is, or know how to make our asymptotes. We don't need this. We have plenty of information to figure this out, that C has to be the right answer. It has to be on there. Last question. This is a polar equation converted to rectangular form. We've actually seen one a lot like it. You can graph this and figure out that it's probably going to end up looking like a circle. But I'm going to go through the algebra with you here. And again, we have our 4 equations, which if you didn't write them down, go back to a couple of slides ago and write those equations down. Me, what I'm going to do is just simply do r is equal to -2 cosine of theta. I want to get rid of the r and I want to get rid of the theta, or even better, the cosine of theta. So what I'm going to do is, I know that cosine of theta is the same thing as x divided by r, which means r is equal to -2x over r. If I multiply both sides by r, I get r squared is equal to -2x. Remember now, I need to get an x in there, so r squared is the same thing as x squared plus y squared is equal to -2x. Now technically we've solved it. We made it rectangular, but this answer right here doesn't really match any of those answers on the top up there. So what that means, I'm going to change the color here. If I got to take this thing, x squared plus y squared is equal to -2x. And now what I need to do is rearrange it, and it looks like I might need to complete a square. So I'm going to do this. X squared plus 2x plus y squared is equal to 0. I'm going to complete this square here. X squared plus 2x plus 1 plus y squared is equal to 0 plus 1. Okay? So now, at x plus 1 squared plus y squared is equal to 1. Which answer choice does that match? That matches answer choice A. So you see the answer there, x plus 1 squared plus y squared is equal to 1. A is the answer choice for that. Well, these are 10 typical problems. We have other problems on the test. Nothing radically different. If you know how to do these and you studied your quizzes and your homework, you should be okay with this.